Welcome, everyone, to Novel Psychoactive Substances, Newly Identified Threats Detected in the Second Half of 2022. This is a copyright slide just to let everyone know that the following material is not authorized for reproduction without express written consent. Thank you for joining us for today's webinar. My name is Mindy Shelby. I'm a member of the clinical team at Aegis Sciences Corporation. This is a brief educational webinar examining the detection of novel psychoactive substances at Aegis Sciences Corporation in the second half of 2022. From this presentation, participants will be able to identify trends in NPS detection in the second half of 2022, as well as be able to identify new NPS detected in the second half of 2022. Those who missed the live presentation or would like to hear it again may find a recording of this presentation on the Aegis website at www.aegislabs.com. Please call 1-800-533-7052 if you need assistance accessing the recording. Novel psychoactive substances, or NPS, are a diverse group of synthetic substances created to mimic the effects of scheduled or illicit drugs. There are various classes of NPS, including designer opioids, designer benzodiazepines, synthetic stimulants, synthetic cannabinoids, hallucinogens and dissociatives, and others. NPS may change frequently as legislation to control specific chemical structures or classes of NPS is introduced. Once an NPS has been deemed a controlled substance, often new or modified non-regulated NPS appear. The focus of this clinical update is to evaluate changes observed in the detection of NPS at Aegis in the second half of 2022. We will start by taking a look at designer opioids. Designer opioids include various classes of compounds such as fentanyl analogs, also called fentanylogs, along with nitazene analogs, utopioids, and others. The prevalence of the top 4 designer opioids of the second half of 2022 are shown here. The most prevalent designer opioid, fluorofentanyl, is often detected with despropionyl fluorofentanyl, which may be either a metabolite of fluorofentanyl or a process impurity. These 2 designer opioids remain the most frequently detected NPS among all NPS classes tested at Aegis. In the first half of 2022, there was a rise in detection of nitazene compounds, which continued into the second half of 2022, with 4-hydroxynitazene, shown in the graph in orange, becoming the 3rd most prevalent designer opioid detected, followed closely by metanitazene. 4-hydroxynitazene and N-desethyl isotonitazene are known metabolites of the designer opioid isotonitazene. However, 4-hydroxynitazene is predominantly detected alone or in combination with metanitazene. It has also been detected with other parent nitazene analogs, so it may eventually be found as a shared metabolite. Metanitazene detections increased throughout 2022, resulting in it becoming the 4th most prevalent designer opioid detected in 2022. Metanitazene was first identified in 2020 and has since been identified as a public health concern as it has been increasingly identified in forensic death investigation casework. The prevalence of other designer opioids detected in the second half of 2022 is shown here. What is evident from the graph is that many different designer opioids were detected. At the bottom of the graph in blue, detection of valerial fentanyl and its carboxy metabolite are shown increasing to peak in September. Although its detection decreased somewhat in mid to late Q4 of 2022, it ended as the 5th most prevalent designer opioid of 2022. Benzylfentanyl detection, shown in gray, increased by more than 70% from January to its peak detection in July, but due to the rise in nitazene compounds and increase in valerial fentanyl, it dropped to the 6th most prevalent designer opioid detected in 2022. The lime green color represents N-desethyl isotonitazene, which is a metabolite of isotonitazene. Isotoniazine was classified as Schedule 1 in the first half of 2022. Indozethyl isotoniazine itself is not explicitly scheduled. It is now being manufactured and distributed as a parent drug, which is likely why its detection has not decreased. The prevalence of despropionyl bromophentanil, shown in pink, also saw significant increases in 2022, rising by more than ninefold from January to December. 4 designer opioids were newly detected in the first half of 2022. These include the utopioid U-47700 and cyclopropylfentanyl, which made an appearance in May and June, respectively, protonidazine, which appeared in March, April, and June, and despropionyl chlorofentanyl, which has been sporadically detected, with the most occurrences in June. Of these compounds newly detected in the first half of 2022, only protonidazine and despropionyl chlorofentanyl were detected in the second half of 2022, each being detected throughout, with protonidazine, shown in yellow, being detected in all months except November. There were 5 new designer opioids detected in the second half of 2022. 4-trifluoromethyl U-47700, dipienone, impepridinyl edenidazine, butanidazine, and flunitazine. Of these, only flunitazine was detected in more than 1 month, being detected in a 3 consecutive month period from August through October. The prevalence of the top 4 designer benzodiazepines detected in the second half of 2022 is shown here. In the first half of 2022, clonazepam, which is in orange, was the most prevalent designer benzodiazepine detected, followed by flualprazolam, shown in the graph in blue. Based on the number of detections, clonazepam remains the most prevalent designer benzodiazepine detected in 2022. Although its positivity in the fourth quarter of 2022 is decreasing, with the number of bromazolam positives exceeding those of clonazepam in December. In January of 2022, flualprazolam and bromazolam had the same number of positive results, but from January to May of 2022, bromazolam doubled, whereas flualprazolam increased by more than sixfold. However, this trend did not continue into the second half of 2022. There's an overall decreasing positivity for 3 of the top 4 designer benzodiazepines, the exception being bromazolam, shown in green, which has continued to increase, more than doubling from July to December. Interestingly, as of December of 2022, the DEA temporarily placed clonazepam, etizolam, flualprazolam, flubromazolam, and diclazepam in Schedule 1 of the Controlled Substances Act to attempt to limit access to these substances. Bromazolam was not included in this list of scheduled designer benzodiazepines, so demand for it may increase if it becomes sought after as a replacement. As of January of 2023, bromazolam detection has continued to increase. The prevalence of other designer benzodiazepines detected in the second half of 2022 is shown here. After the top 4, flubromazolam and its metabolite alpha hydroxyflubromazolam, shown in the graph in yellow and orange respectively, were the next most prevalent designer benzodiazepines detected, with detection throughout 2022, the lowest prevalence being in December. Flubrorazepam, shown in the brick color, was detected every month of the first half of 2022, but in the second half was detected less and more sporadically. Detection of diclazepam and or its metabolite dilorazepam occurred over a consecutive 3-month period from February through April, and then again in September and October. 3-hydroxyphenazepam, shown in purple, was sporadically detected in April, June through August, and again in December. Deschloroetizolam, shown in pink, was newly detected in February of 2022, with detection in all subsequent months of 2022, increasing to peak in October. Adenazelam was also newly detected in 2022, appearing only in March. In the second half of 2022, its metabolite indesmethyladenazelam, shown in lavender, was detected in August, but predominantly in December. Metizolam and the meclonazepam metabolite 7-aminomeclonazepam were the only designer benzodiazepines newly detected in the second half of 2022. Metizolam was detected only in October and November, whereas 7-aminomeclonazepam was detected August through December, with the exception of November. Synthetic stimulants tested at Aegis include analogs of amphetamine and methylphenidate, as well as cathinones, which have been erroneously sold as bath salts. The prevalence of the top synthetic stimulants is shown here. Eutalone, shown in blue, is a synthetic cathinone and was the predominant synthetic stimulant detected through the fourth quarter of 2021. However, as of January 2022, prevalence of eutalone began to decline. Eutalone was added to Schedule 1 of the Controlled Substances Act as a positional isomer of pentalone, which was placed under Schedule 1 in 2017. In the first half of 2022, eutalone detection declined and pentalone, shown in the mustard color, increased to become the most prevalent synthetic stimulant detected in the first half of 2022. Since pentalone is a controlled substance, the increase in detection was suspected to be due to it being a metabolite of the novel synthetic stimulant N,N-dimethylpentalone, which was added to Aegis synthetic stimulant testing in August of 2022. In the second half of 2022, N,N-dimethylpentalone, shown in gray, and its metabolite pentalone were the most predominant synthetic stimulants detected, followed by eutalone. Other synthetic stimulants detected in the second half of 2022 are shown here. Detection of alpha pyrrolidinohexanophenone, or alpha PIHP, shown in blue, occurred in all months except January and is the third most detected synthetic stimulant overall in 2022. N-cyclohexylmethylone, shown in the camel brown color, was newly detected in August of 2022 and was detected in all remaining months of the year at such a frequency as to become the fourth most prevalent synthetic stimulant of 2022, followed by alpha pyrrolidinohexyophenone, or alpha PHP, shown in peach, and then followed by butylone in yellow and dibutylone in navy blue. Alpha PHP was detected throughout the second half of 2022, with the exception of August. Butylone prevalence in 2022 was somewhat sporadic, being detected in January, April, July and August, and October and November. Dibutylone, another positional isomer of pentalone, was first detected at Aegis in January of 2022, then did not make an appearance again until May and June. Its detection continued into July and August, but then it was not detected again for the remainder of 2022. Trifluoromethylphenylpiperazine, or TFMPP, shown in maroon, was only detected a single month in the first half of 2022, but during the second half of 2022, it was detected in 4 of the 6 months. 2-fluoroamphetamine was first detected at Aegis in August of 2021. In 2022, it was detected only in August, nearly a year after it was last detected in October of 2021. In the first half of 2022, there were a number of synthetic stimulants that were newly detected, including N-ethylhexadrone and N-ethylheptadrone, which were each only detected in a single month. Fluorinated amphetamine and methylphenidate analogs, 3,4-fluoroamphetamine and 4-fluoromethylphenidate, were also newly detected in the first half of 2022. However, with the exception of 4-fluoromethylphenidate, which was detected in July, none of these compounds newly detected in the first half of 2022 were detected in the second half of 2022. However, 5 other synthetic stimulants were newly detected at Aegis in the second half of 2022, including N-dimethylpentalone, N-cyclohexylmethylone, N-butylhexadrone, methylene dioxy-PV8, and dimethylone. Of these, only N-dimethylpentalone and N-cyclohexylmethylone were detected in more than a single month. The top 3 most prevalent synthetic cannabinoids detected in the second half of 2022 are shown here and include MDMB, 4-EN pinaca, and its butanoic acid metabolite, 5-fluoro-MDMB/EMB pica and metabolites, and metabolites of 4-fluoro-MDMB butanoica. Detection of MDMB, 4-EN pinaca butanoic acid, shown in dark blue, increased by approximately 86% during the second half of 2022, and it remained the most prevalent synthetic cannabinoid detected at Aegis in 2022. 5-fluoro-MDMB pica, metabolite 7, was the most frequently detected metabolite of 5-fluoro-MDMB/EMB pica, and its detection increased to peak in May with an overall decreasing trend through the remainder of the year. Detection of 4-fluoro-MDMB butanoica and butanoic acid, the darkest shade of red, was steady in the first half of 2022, but saw an overall increasing trend in the second half of 2022. These top 3 synthetic cannabinoids, along with PB22-3CL, were the only synthetic cannabinoids that were detected in every month of 2022. The prevalence of other synthetic cannabinoids detected in the second half of 2022 is shown here. What is first noticeable is the large number of compounds detected, many of which were detected for the first time. These include ADB butanoica and metabolite, ADB fubiata and metabolites, ADB 4-EN pinaca, ADB hexanoica metabolite, MDMB 5-bromo-inaca, 5-fluoro-EMB pica HP/5-fluoro-MDMB pica M2, beziohexoxazid, chipiata, and JWH-018HP. Many of these were added to synthetic cannabinoid testing at Aegis in August of 2022. Of the newly added compounds, ADB butanoica and metabolite, shown at the bottom of the graph in light and dark aqua green color, together were the most frequently detected and quickly became the 4th most prevalent synthetic cannabinoid in 2022, rivaling the prevalence of PB22-3CL, shown in gray, which was detected for the entirety of 2022. ADB fubiata and metabolites were also newly added compounds that became some of the more prevalent synthetic cannabinoids detected in 2022. In addition to ADB butanoica and ADB fubiata metabolites, MDMB 5-bromo-inaca was the only other newly added synthetic cannabinoid that was detected for the remainder of 2022. Other newly added compounds, including ADB 4-EN pinaca, ADB hexanoica metabolite, beziohexoxazid, chipiata, and JWH-018HP, were only detected in 1 to 2 months of 2022. 4 compounds of the hallucinogen dissociative MPS class were newly detected in the first half of 2022. These included 2-fluoro-deschloroketamine and its metabolite 2-fluoro-deschloronorketamine, 3-fluoro-PCP, and deschloro-N-ethylketamine. 2-fluoro-deschloroketamine and its metabolite 2-fluoro-deschloronorketamine first appeared in April, and metabolite was detected throughout the remainder of 2022, becoming the most prevalent hallucinogen dissociative compound detected in 2022. 3-fluoro-PCP was first reported in March and was detected through June and then again in September and October. It ranks as the third most prevalent compound in the hallucinogen dissociative class detected in 2022. Deschloro-N-ethylketamine was only detected in May of 2022. In the second half of 2022, hydroxetamine and the PCP analog 3-hydroxy-PCP were the only newly detected compounds in the hallucinogen dissociative class. Hydroxetamine was detected only in August of 2022, whereas 3-hydroxy-PCP was detected September through November, yet was the second most prevalent hallucinogen dissociative detected in 2022. Interestingly, deschloroketamine and its metabolite deschloronorketamine, which have not been detected since October of 2021, were detected in November and December of 2022. And last but certainly not least, the NPS other category currently consists of three compounds: xylazine, tianeptine, and phenibut. Xylazine continues to be the predominant NPS detected in the NPS other category. The prevalence of xylazine and its metabolite 4-hydroxyxylazine are shown here. Xylazine is a sedative used in veterinary medicine and is not approved for use in humans. It has emerged as a drug of misuse and as an adulterant in illicit drugs, including fentanyl and heroin. Xylazine detection approximately doubled in the first half of 2022, but increased by more than fourfold in the second half of 2022. Prevalence of additional compounds in the NPS other category are shown here. Phenibut is a synthetic form of the neurotransmitter GABA and is typically used for anxiolytic and psychotropic effects. Detection of phenibut, shown in yellow, increased by approximately threefold in the second half of 2022. Tianeptine, sometimes referred to as gas station heroin, is structurally related to tricyclic antidepressants and is a prescription drug used as an antidepressant in Europe, but it is not approved by the FDA for medical use. Tianeptine has activity at opioid receptors and has recently been in the news as various states are scheduling it as a controlled substance. Otherwise, it has been sold as a supplement in the US and has been legal in many states. Although consistently detected since March, tianeptine prevalence fluctuated, with its highest detection being in July. And that concludes our webinar. But before we wrap up, I want to tell you how to get in touch with us for additional clinical support. The individuals pictured on your screen are my colleagues, the clinical scientist team of Aegis Sciences Corporation. The information covered today is also available in written form, accessible online at www.aegislabs.com. Go to resources, then clinical update. You are also welcome to direct questions to the phone number or email address on your screen. Thank you for joining us today. I hope this has given you additional insight into new NPS observed in 2022, as well as trends in NPS detection at Aegis Sciences Corporation. Have a wonderful day. Thank you.